The mobility of lithium ions inside battery components is a key property for the design of better lithium batteries. Using molecular dynamic simulations, it's possible to gain insight into the diffusion of lithium ions at the atomistic level. Let me show you how this is done with the Amsterdam modeling suite. I will use a partially lithiated sulfur cathode for this demonstration, but it will work in the same vein for other lithiated materials. This particular structure was generated in a previous tutorial on the simulation of discharge voltage profiles. Here I have set up an MD simulation with the reactive force field ReaxFF at 1600 Kelvin. I will follow the online tutorial and only simulate 110,000 steps, which will be enough for this demo but should be increased for production runs. Once the calculation is finished, we can inspect the trajectory with arms moving. To calculate the diffusion coefficients for the slope of the mean squared displacement, go to MD Properties, MSD. In a pop-up dialog, we ask to exclude the first 2000 steps from the calculation to account for equilibration and specify that the mean square displacements should be calculated for lithium atoms only. All these values are explained in more detail in the online tutorial, for which I put a link in the video description. To start the calculation, press the button Generate MSD. Within a few seconds the calculation should be done and the results are displayed in a graph window on the right. The MSD is the red straight line. If the MSD line is not straight, it means that you need to run a longer simulation to gather more statistics. The blue curve corresponds to the diffusion coefficient D. It should ideally be perfectly horizontal. Here the blue curve seems to converge to a value around 3.73 times 10 to the power of minus 8 square meters per second, which is the final result for the lithium diffusion coefficient. Calculating the diffusion coefficient at 300 K would require a very long trajectory. However, it is possible to provide an upper bound to the lithium diffusion by means of extrapolation from elevated temperatures. How that is done is also outlined in the online tutorial. That's it for today. I hope you found this video useful, and as always, feel free to leave a comment or question below this video.